Today we are going to practice adding, subtracting, multiplying, and dividing with complex numbers, or numbers that have an imaginary number within it. So a number of the form a plus bi, where a and b are real numbers, and I is equal to radical negative 1, just like yesterday, is called a complex number. So in that blank, let's put complex number. When we add or subtract complex numbers, you add and subtract the real pieces together, and you add or subtract the imaginary pieces together. And that's all those first two things say. Let's practice. First one we have 4 plus 2 is 6. 3i plus 5i is 8i. You don't try to combine it, that's it. Moving over to the right, with the subtraction, just be careful. 5 minus 2 is 3. 3i minus 8i is negative 5i. 8 plus 3 is 11. Negative I plus negative 7i, just be careful, it's negative 8i. 7 minus negative 1 is 8. 4i minus 3i is I. 3 plus 1, 4. 2i plus negative 2i is 0, so we can just write a 4. 6 minus 3 is 3. I minus I is 0. Negative 9 plus 9 is 0. I plus 6i is 7i. 1 minus 1 is 0. 2i minus negative 9i is positive 11i. So adding and subtracting is easy. Just add the real numbers and add the imaginaries together, and that's it. Moving on. When we multiply complex numbers, we have the following terms. The blank of a complex number is the real number 1 plus 0i, or 1. That's the multiplicative identity, meaning if you multiply by that, you're going to get the same thing back. So multiplicative identity. The blank of a plus bi is a minus bi. That's the conjugate. We've talked a little bit about conjugates already when we did radicals. It's going to be the same idea. You change the middle sign. And the blank of some a plus bi number is 1 over a plus bi. Well, when you flip a fraction, it's called the reciprocal. That's an RO. Write the complex conjugate of each number. Easy. All you have to do is change the middle sign. So the conjugate of 2 minus 5i is 2 plus 5i. The conjugate of negative 6 minus 9i is negative 6 plus 9i. The conjugate of negative 4 plus 1/3 i is negative 4 minus 1/3 i. So conjugate is easy. Again, you hope to get those problems on the Regents exam. Find each product. Well, let's look at the first one. It's like FOIL. It's like everything we've been doing before. 1 times 1 is 1. 1 times 2i is a positive 2i. 5i times 1 is positive 5i. 5i times 2i, just be careful here, it's going to be 10i squared. So I have 1 plus 5i and 2i is 7i, plus 10. I squared is a negative 1, if you remember from yesterday. So I can still do a little more work here. I change that to a negative 1. 10 times negative 1 is negative 10. Plus the 1 you have at the beginning is negative 9, plus 7i. And that's your final answer there. Let's do another one of them. 2 minus 3i quantity squared. Remember when we have something squared, it's a good idea to do 2 minus 3i times 2 minus 3i like that. And then FOIL. 2 times 2 is 4. Minus 2 times negative 3i is a negative 6i. Negative 3i times 2 for that inside is negative 6i again. Negative 3i times negative 3i is a positive 9i squared. So we'll have 4 minus 12i plus 9 times I squared is a negative 1. 9 times negative 1 is negative 9, plus 4 is going to be a negative 5, minus 12i. I'm going to do one more. I will skip this one, ask you guys to do this on your own, and I will do this last one with you guys. So, foiling this one. 1/5 times a 4 is 4/5. 1/5 times 2i is 2/5 I. On the inside, 4 times negative 1/10 is going to be negative 4/10 I. And then negative 1/10 I times 2i is going to be a negative 2/10 I squared. 2/5 I minus 4/10 I is 0. So we really have 4/5 minus 2/10 times negative 1. Well, 4/5 plus 2/10 is going to be 5/5, which is 1. So make sure you can deal with fractions okay here. You guys again try that one above where it says to find the product for the negative 4 minus I and the negative 4 plus I. The next piece. Find a multiplicative inverse of each of the following in A plus BI form. Well, the inverse, what you do is you take the inverse is the reciprocal. So 1 plus I is going to be the same as 1 over 1 plus I. Alright, just like with radicals, you're not allowed to have a I in the denominator, just like you can have radicals in the denominator. So we multiply by the conjugate, which is 1, that's a positive 1, minus I, and then 1 minus I. In the numerator, 1 times 1 minus I is 1 minus I. In the denominator, it's FOIL. 1 times 1 is 1. Outside is negative I. Inside is positive I. Last is negative I squared. So I'll have 1 minus I over negative I plus I is 0. I squared is a negative 1. So that's really 1 minus negative 1, which is a 2. I'm going to have you guys try the middle problem. I'll do the last one. So we have 2 minus 1/2 I. It's going to be, first we'll say it's 1 over 2 minus 1/2 I. And then we multiply by the conjugate, which is 2 plus 1/2 I, in both the numerator and denominator. 1 times 2 plus 1/2 I for that numerator is 2 plus 1/2 I. In the denominator, we have 4 plus I minus I minus 1/4 I squared. Again, these cancel, and they should. I squared, we know it's a negative 1. So it's really negative 1/4 times negative 1, which is a positive 4th, plus 4 is going to be 17/4 if you keep it as a fraction. 2 plus 1/2 I. And I could go further with that, but I am not going to at this point. I'm going to leave it just like that. So we've added, subtracted, and multiplied. Let me show you a little bit with dividing here. For dividing, it's just like what we just did with this piece above, actually. What you have to do is, I'm going to first change this so it looks like that. And then I'm going to multiply by the conjugate. 8 plus 4i times 1 minus I is a FOIL problem. 8 times 1 is 8 minus 8i plus 4i minus 4i squared all over 1 minus I plus I minus I squared. The numerator combined like terms. I'm going to show a little less work here. I squared is a negative 1. So this is just a 4 plus 8 is 12. minus 4i over, those cancel, I squared is a negative 1, it's over 2. Now we see that a 2 goes into 12, 4, and 2, so we reduce it to a 6 minus 2i over 1. And what I'm going to say is try this problem right here as well. Do not do these ones. Okay, don't do those ones there, because I just want to see if you know how to do this, and I've used a lot of the video time already. Okay, see you tomorrow.